Hello everybody and welcome to Work Against the Grain. My name is Jeff. What I want to show you today is how we can put together a segmented bowl for turning. We're going to take the Vectric software, create some segments, glue them together so that it's ready to put on the lathe and turn. Now when you're making these segments, normally they're done on a table saw or a chop saw, but I want to show you how we can make some exact segments on the CNC machine, glue them together, and then you can take it over to the lathe and turn it into a nice bowl. Now this is the one that I did for the demonstration purposes. Now I'm not going to show you how to turn it on a lathe. If you want to see some really good turning, Carl Jacobson is just an absolute master. My turning skills are not really for public consumption yet. I'm getting a lot better, and maybe one day I can bring you some wood turning, but I want to focus on how we made the segments within the Vectric software and then cut those out, glued them together, and got it ready to turn so that we could make this nice little bowl, okay? So here we go. I'm going to explain the measurements that are really important first. Then we're going to go into the Vectric software, show you how to create the segments, and then ultimately cut them out on the CNC and glue them together. So thanks again for being here and watching Work Against the Grain. My name is Jeff.
Okay, if you can imagine this here as a 12 segment ring, and that's what we're going to focus on. Now you can cut out rings in just about any number of segments. I'm only focusing on a 12 segment ring, and the math and things that we're talking about here is specifically for a 12 segment ring. All segments are made exactly the same, but there are some very important measurements and angles that must be exactly correct for this to glue together perfectly. The first is this long edge. Now, depending on the diameter of the ring, that is going to tell you how long this edge needs to be. And there are some mathematical equations that we'll show you in a little bit that explain how long that needs to be based on the overall diameter of the ring. The second thing is, because we are cutting a 12 segment ring, this angle right here needs to be 75 degrees, which means if you were cutting this on a chop saw, you would set your chop saw to 15 degrees, and then when you cut that, it would make this interior angle here and the interior angle here 75 degrees, okay? And again, it's either a 15 degree miter on the outside with a chop saw that creates the 75 degree internal angle. Then finally, you need to know the width of the segment, which is the distance from right here to right here. And depending on the diameter of the overall ring, as well as the diameter of this internal part or the bowl part, that's going to tell you the width of the segment. Now, the fourth measurement that I don't have on here would be the thickness. In our particular case, for our particular bowl, we use 3/4 of an inch thick. And again, that's a measurement that I'll show you when I show you the graph drawing that we did to determine how wide our rings needed to be and how thick and what the angles were, etc. So again, these are the measurements: long edge, 75 degree angle, and our width. Those are the measurements we must know in order to cut these out properly and design them within the Vectric software. Okay, let's go ahead and take a look at this slide here. I will try to attach this PDF in the description box if I can figure that out. Anyway, we talked about in the previous slide the long edge calculation and how we determine that. So if you can imagine this area here as one of our segments, one of our 12 segments, then we know that the diameter of our ring times pi, or 3.142, equals the circumference. If I want a 5-inch diameter ring times pi, that means that I have a circumference of the ring of 15.71 inches here. Divide that by the number of segments that you want to use, and you get what your long edge needs to be. That's what we're going to focus on the CNC machine when we create this in Vectric. Now, we also need to know this inside angle on the CNC, or what the miter angle is if you're doing it on the chop saw here. So what I did was I included the angles here depending on the number of segments. This is your miter angle, and this is your interior or included angle. So we are doing a 12-segment bowl, and in order to do the 12 segments, your miter angle is 15 degrees, meaning your interior angle here is 75 degrees. Then you move to the width. How wide do I need it to be? Well, if you imagine this as a piece of 11-inch graph paper here, and the red line is the profile of your bowl, what you want to do is find a center line, as I have here, and imagine that you need to cover up what your profile is. Then you draw your squares, because you already know what your long edge needs to be and what your angle needs to be. Now you need the width, which is the amount of material that you need outside of your bowl profile. Now, if you want to do a lot of turning, or you want to allow for a lot of mistakes, as sometimes I do, then you're going to want this width to be quite wide, and you'll machine it down to the profile or the thickness that you want. If you're a very good turner, maybe you cut that off right here, and you don't have to make them as wide because you're really good at what you do and you don't have to do a lot of machining. So now that you have your long edge based on the diameter of your ring here and the circumference, you have your angle here, which I gave you all of the angles depending on the segments. I gave that to you up here. And now you've drawn this on a piece of graph paper so you understand how wide each segment needs to be. We can now jump over to the Vectric software and begin to model our segments. Then after we model them, send them to the CNC, we'll show you how to cut them out. So let's have a look now at how we're going to design and model our segments for our 12-segment bowl. Okay, here we are in the Vectric Aspire software, and we're going to go ahead and hop over here and create a new file. We'll make it 13 inches along the X, 6 inches along the Y. We're going to make it 3/4 of an inch thick. XY0 here in the lower left, working in inches, standard modeling resolution. We'll use cherry wood for the appearance, and click OK. This entire operation, we're going to use the Draw Polyline tool, and you'll get this dialog box. And we're going to start our first segment right here by clicking just like that. And we know that the length, based on our math, needs to be 1.309 inches. That was our long edge length in our segment for a 5-inch diameter 12-segment ring. Hit enter, and now we have our long edge dialed in just exactly as we wanted it. Now we have the line segment here, and we need to tell Vectric what to do with that. So I know that I want the length of this to be 2.0 inches. And we know that we want our angle to be 75 degrees. Now if you'll look here in this box right here, you'll notice that it goes minus and plus depending on which side of your line you are on. Below the line will be negative angles. Here is your 0. Below the line is negative angles. And above the line is positive angles. Keeping in mind that a circle is 360 degrees around. So if we're here at the 0 mark and we were to come like this all the way around to here, we would be minus 180 or 180 degrees. Now, because we know we want our angle to be 75 degrees, then because we're working below the line, we're going to want to adjust this to minus 105 degrees. And so we'll come to angle and go minus 105. And we will select enter. And Aspire knows that we now have a 2-inch length with a 105 degree angle. And now we're going to go ahead and click close. And this is the first long edge. Here is our 75 degree angle on the inside, 15 degree miter, or in relation to our center line, it's minus 105 degrees around. Now we're going to go back into the draw polyline, and we're going to come back to here where our 0 was, where we first began, and we're going to start right there. And now we're going to do the same thing. We're going to come like this, keeping in mind that this is our 0, or our 180. So now we're going to come back this way to minus 75 degrees, because remember, we want this angle in here to be 75 degrees. So you can go ahead and set your line segment just like that, and you can go long or short, whatever you'd like. You can see there that the cursor changes depending on where you are. And we're going to go ahead and come here to 75, select, and then we're going to come over here and connect the two right there and select close. And there we go. There is our first segment for our 12 segment 5-inch diameter ring. Now we need to have 12 of these, so we're going to go ahead and select all of our line segments, all of our vectors, and we're going to go ahead and group those objects so it becomes one. And while it's selected, we're going to come down here to create a linear array of copies. We want 2 rows with 6 in each row and a 1/2 inch gap between them. We are not going to group the copies, and we're going to select copy. And we will take this group like that, select close, select our align selected objects, and let's go ahead and put it in the center of the workpiece, close. Pop over here to our tool paths with our vectors already selected. We'll select the profile tool path. We're going to start at 0. We're going to cut it down 0.78 so that we cut all the way through. I'm going to use an 1/8 inch end mill, as you see here. And we're going to cut these on the outside of the segment so that we get the full length of our long edge and that our angles are correct. Because if we cut on the inside of the line, we are not going to get the tight angles. You can add tabs if you'd like. I have found that they are not necessary when cutting these segments. Name your toolpath, select calculate. The software will tell you you're cutting through the material, which is what we want. Select OK. And there you have it. Those are your tool paths. And we can go ahead and select preview all tool paths. The machine will then demonstrate to you what it will look like with all 12 cut out. Double click this material, the waste goes away, and you've got, ladies and gentlemen, 12 perfect segments to create your 5-inch diameter segmented ring. Close. Let's go ahead and save our tool paths to file and follow those appropriate steps to be able to save and get the tool paths out to your CNC machine. It's that easy. The segments, if cut properly and laid out properly, as I've shown you here, you will cut out 12 perfect segments. And hang in there, because coming up next, we're going to cut them out on the CNC, glue them all together, and show you what the ring looks like.